I've been able to respring those contacts on these switches. I can't show you actually doing one of them because it's too difficult to support the board and two screwdrivers at the same time. However, I can show you the method. So if you can look at this contact here, what I did was put the small screwdriver underneath the contact and then use the bigger screwdriver to press the contact down. And that needed doing for these two and these two contacts. This contact had been pushed out of the way, so I realigned that, and on the surface of it, it would look like that fixed the problem, but it hasn't fixed the problem, because it looks like with this board there's a number of problems, and the problems are problems because they're intentional. What do I mean by that? Well, I mentioned before this bridge that had been put across to bypass these contacts on the switch so it would work for 80 metres at least. Well, if you look more closely, there's more that's gone on than that. This coupling shaft between the three wafers, it's got connections on it too. So the moving plate here on these two wafer switches are actually connected together through this coupling shaft, which actually bypasses this whole section. And as I said, there was an input chain circuit coming in on here as well. If you look underneath the board, perhaps like that, this FET on the bottom was originally on the top. There's been a wire put across from the wafer on the end of this start of the switch here. There's a bridge going across there, and this section here is actually the preamp FET. So there's been a lot of work done on this board, quite intentionally, and I think what's happened is that there's been possibly a lightning strike or some sort of damage to the board. This is one of the few boards that there isn't spare for the transceiver. Quite a few of the others there's spare boards of. And so what's been done is that this board has been modified so it can at least be used for 80 metres at the sacrifice of some of the other bands. And perhaps the original FETs have been damaged, and they're meant to be 3SK35s, or this is a 3SK45, and there's a 40673, the one underneath, which is meant to be another 3SK35. So I think there's been a lot of work done on this board to keep it going, even where this connector comes off here and bridges over the coupling shaft. I don't think that's original either. So what's going to have to happen to the board, I think, is to look at the complete board, remove these bridges, including the bottom one, and just trace connections and find out what it is that's faulty on the board, and why so much bypassing has been done here. If it was just a matter of replacing FETs, why weren't the FETs just put back in the original positions, even if they might have been different connections, and why has all this been bypassed? I think the contacts on the switches have probably been lifted intentionally so that these other modifications can work. And why would you do that? I don't know. But obviously there's been a big problem with this board, and they've gone to a heck of a lot of trouble to try and make it work to some extent, and it certainly works on 80 metres alright, but it doesn't work properly at all on the other bands. So I'll have to get back to you in the next video with the result of all this, but I'm going to have to overhaul the whole board, I think. Otherwise, if I start lifting all these bridges off and expect it to work properly, it probably won't, because if it did, they wouldn't have put them on in the first place. So a bit more investigation is going to need to be done. Anyway, that's all for now.